Good evening. My name is Adetunji Adewuyi. I'm here to present to you secure coding best practices. This is in fulfillment of my cybersecurity course in Metro State University. The purpose of this presentation is solely for educational purpose, and I'm not liable for any information or any demonstration that might cause damage which you might have acted upon. So I made a disclaimer. I'm going to go into secure coding quickly and tell you what are the advantages, disadvantages, and why we need to have our code secure. Before we go into the whole thing, I just quickly want to give you a scenario. I'm sure everybody must have gone online to buy things, maybe on Amazon. You have gone online to deposit money or to withdraw money or to transact money from one account to another. You've done so many things online, but you are comfortable. You felt at peace when you are doing it. You are not bothered about your information or your data being taken off. It's the work actually, the secure coding that really helps you to have that confidence. If you have probably done a transaction before and you got stopped or your details were stolen and your credit cards were probably hacked, you would have think twice when you want to go online to do anything. So to cut the long story short, I'm going to go into secure coding like I said, and I would try to tell you what we go through from with the objectives. We'll talk about secure coding. Why do we need secure coding, or why do we have to adopt the practices of secure coding? The risk of insecure coding, and then we have the secure coding best practices, which I'm going to make mention of, and then I'm going to show you hands-on or a little demo about secure coding, talking about encryption. When we talk about secure coding, they are standards that governs the coding practices, techniques, and decisions that developers make when developing an application. The aim is to ensure that developers write code that minimizes security vulnerabilities. Complexity sometimes determines security. So sometimes the more the complex the code is, or the more the logic behind the code, the more the requirements of the code, maybe data secure, maybe sensitive data, then you should think about you should think about following the principles of secure coding, because you don't want to leave, or you don't want to break the confidence of the people that consume your product, that goes online to shop. So, and that might even, the vulnerability might even lead to damages. So companies sometimes pay a lot of money when there's a breach in contract, or where there's a leakage in their data or information. So this standard encourages software developers to take safest approach, even if it's not the fastest. I'll stop a little bit here. Programmers are sometimes eager to push codes. After testing, then you push your code, thinking that the firewall for the organization is okay, or the username and password that we have is okay. But that is not okay. When you follow secure coding, it will tell you more. There is more to security. There is more to securing your code than just password, username, or firewalls. Why do we need secure coding, or why do we have to follow the practices? One, it removes commonly exploited software. It prevents cyber attacks from happening. Then optimizing for security from the start helps reduce long-term costs which may arise if an exploit results in the leak of sensitive information. I'll take you back to 2017, a story of Equifax. There was a breach of security, and information were leaked. That cost them a lot of money. Risk of insecure coding. That is, if you don't secure your code, what are the risks? There are a lot of risks. An insecure application lets hackers in. When hackers come in, there are a lot of damages. You can't undermine what an hacker can do when they get hold of your system, or when they if they are able to go into your application or to go into your system environment having one foothold, then they cause damages. They can take direct control of a device or provide an access path to another device. This can result in denial of service to a single user, and not only single users, even multi-users. All systems could be grounded just because of one vulnerability. According to OWASP, there are 14 areas to consider when you are talking about secure coding. There are checklists. This 14 checklist might not be applicable to you. Like we said earlier, it might depend on the complexity of the program. It might depend on the data, kind of data you're working with. If they are security, if they are secure data, if they are sensitive data, then you need to think about all these practices. But like I said, we're going to talk about 5 most important. I won't say most important anyway, but I'm just going to pick 5 and talk about that because of time. So the top 5 secure programming best practices to help protect against vulnerabilities are security by design. That's why I pick this security by design. Is for every application, there must be a design first before we now go into whatever. Even the logic will come first, then the design follows, and then security must be behind almost everything. It should be our priority when we are creating our design. So it starts from the beginning and then you incorporate it. We'll talk about password management. We'll talk about access control, cryptographic practices, input validation, and output encoding. There are 14, but we are just picking these 5. Now, security by design. It should be a priority of every developer. For every application, there should be security. Not about firewalls, not about username and password, but there should be level of security. This approach should put security first because it tends to pay off in the long run. This approach reduces the future cost of technical debt and risk mitigation. An analysis of source code should be conducted throughout the software development lifecycle, and security automation should be implemented. Now, talking about password too, is the common security credentials that we often have. Everybody is used to password, but is the weakest point in many softwares. And so people go through phishing, social engineering to steal this password. And once they get hold of that, if you don't have another layer, then the system is vulnerable and there are a lot of damages that could be caused. So observing secure code practices help limit risk. It's advisable for admin to enforce adequate password length and complexity to withstand any typical or common attacks. We did this in the lab where we have about 15. We minimize, that is, whoever is forming a password should not use less than 15 characters. And that helps because for the more the characters, then the harder for any hacker or anybody that is trying to exploit your system to get hold of your system. Access control. In response to requests for sensitive data stock information, a default deny approach to sensitive data is a good approach until user is authorized. So what we're trying to say here is whenever you have an application that holds data or that requires exchange of data, then those data by default they should authenticate whoever is going to have access to it by default. Don't assume that everybody that are able to log in should be able to have access to. No, there should be levels of security. So privileges should be limited, number 1. Then there should be a restricted access to secure data except it is needed by a user. And this is where I could tell you that some people actually use multi-factor authentication, where you have to have, for you to access or for you to log in, then you have to have a call. So when you confirm that call from your phone, then you have access into the system. So we talk about cryptographic practices. This is a situation where you want to send an information via email. It might not be email through, but you might want to send information to someone elsewhere. Your information can be hijacked online. So you encrypt your information, especially when they are vital. You encrypt it and then you send the key to the to the to the person, or to the person you are sending the information to the recipient. So the recipient takes the information and as well take the key to decrypt it. Without the key, you cannot get the information that is sent. So even if it get lost or you hijack it, you might not be able to read it except you have the key. Then we have the input validation and output encoding. There is need to identify all data input and sources, and that's what gives you the opportunity to set a level of access or priority. If you have sensitive data like social security numbers in the database, then you have to secure that. You have to make sure that you encrypt it in there. And even when you are working on the front end, when you type in those social security numbers, it has to be encrypted. Maybe the last four digits could show. That's a good practice. There should be a standard routine for output encoding and input validation. So here I'm going to go into my Visual Studio 2019. The code is written just to save time, and I'm going to quickly just run through. These are my libraries here. I have the system library, the system.io input and outputs. I have the security cryptographic class that I'm making a reference to so that I can use some of those objects, some of those property inside this particular library. Then I have the text, and then I have the XML serialization. I declared three variables here. The first one is CSP. That is to hold an instance of an object, which I'm creating here, and I passed in 248 bits so that you can send it and save it in the CSP. Then I created two more private keys, which are read-onlys. I have private key and I have public key, two more keys. Here, I made a constructor of this application. The constructor bears the same name with a class, and this is it. So here, I initialize my variable, the private key and the public key, setting the private key to true and setting the public key to false, the parameters. Then I made a declaration of a method that says get public key. It helps to get the key. And here I have two variables and I'm returning one of them, which is a string writer. I'm returning my string writer here. I have another method called the public string encrypt. This helps to encrypt. This method actually prompts the user to type in something. When you type in, whatever you type in, it encrypts it. So all the codes that you're seeing in between here are doing the encryption. And by the time they finish doing the encryption, then they display it as an encrypted format. There is one more method down here, which is called decrypt. So whatever is being encrypted can be passed into this. And I'm going to use these two methods. One, we take in those values and we encrypt it, while the other one will take in that particular encrypted value and then brings it out again and return it as a normal value or normal text that you have typed in. So this is my static void main. That is where my program actually runs. I made a declaration. I created a variable to hold the object of this class, and then I initialized all these other things I did here just to make my program run. I'm going to run this program. This program can run on Linux, it can run on Macs, and then it can run on Windows. So I'm using two windows. I will have to drag my console environments from my second window down. And it says enter your text to encrypt. So I'm going to do this assignment, or let me say project, cybersecurity project. project encrypted. So here it encrypted everything, and then it says press any key to decrypt. So when I click here, my decrypt method comes in and takes all this value and put it back and give me what I have done there. And you can see that it says decrypted message, cybersecurity project encrypted, which is the same information that I have at the top here. Thank you.